In this lecture, we're going to discuss the speed limit of our universe. So is there a limit to how quickly an object can move within our universe? So let's suppose we have an object with a mass m that could be a macroscopic object, for example, a tennis ball, or a microscopic object, for example, a proton. Now let's suppose this object has a mass m and a velocity v. Now, the momentum of such an object is defined using the relativistic momentum equation. So P, our momentum of that object, is equal to the mass multiplied by its velocity divided by the square root of 1 minus v squared divided by c squared, where c is the speed of light in empty space. So let's begin by asking the following question. Can velocity of such an object with mass m be greater than c, the speed of light in a vacuum? So to answer this question, let's actually use the relativistic momentum equation. So let's suppose that the mass of the object is in fact greater than the speed of light. Let's see what happens according to this relativistic momentum equation. So if the velocity of the object with mass m is greater than the speed of light in a vacuum, then we see the ratio in the denominator v squared divided by c squared is greater than 1. So if this fraction is greater than 1, then 1 minus a number that is greater than 1 gives us a negative value. And the square root of a negative value gives us an imaginary value. Now, because this gives us an imaginary value, we see that the velocity of an object with mass m cannot actually exceed the speed of light in a vacuum. It cannot be greater than c. So, let's examine question 2. Now, we're going to use the same relativistic momentum equation to answer if our velocity v can actually equal the speed of light. So let's suppose we have an object with mass m whose velocity v is equal to c, the speed of light in empty space. Now, if this condition is in fact true, then that implies v squared divided by c squared is equal to c squared divided by c squared, or 1. Now, if this is equal to 1, then this ratio is, or this radical is equal to 0. So the square root of 1 minus 1 gives us the square root of 0, which is equal to 0. But this would actually mean, based on this equation, that the momentum of our object with mass m that is moving at the speed of light in a vacuum is infinitely large, because mc divided by 0 gives us infinity. Now, this basically is an impossibility, because to increase the momentum of any mass m to an infinitely large number requires an infinite quantity of energy. And of course, that's impossible. We don't actually have an infinite quantity of energy within our universe. So, we conclude the following important point. The speed of any mass m cannot actually equal to or exceed the speed of light in a vacuum, given by 3 times 10 to the 8th meters per second. The speed of any mass on Earth or in our universe has to be less than the speed of light within our vacuum.